Hi, good morning everyone. I am Johan Brichau and this is my colleague Kris Gybels. We're software engineers at Instantiations, and this morning we will present to you the Vast AI Assistant, which is the integration of large language models into the Vast development environment. And if you've been watching our UK Smalltalk presentation a couple of months ago, you will of course see some differences which we have been doing over the past few months, but we will present some things again, of course. But it's very much, again, a point in time. So after this presentation, we still continue developing and more ideas. So we wanted to have more already to show, but yeah, there's always work and time. So we'll just show you what we have right now, interesting things. So first part is, first I'll present, okay, what are the goals? What is the long-term vision more about the Vast AI Assistant? What's driving our development, the way we approach the Vast AI Assistant? Then Kris will show you what it actually is, the AI assistant. So we'll switch a little bit. We're making things complicated here. So, and then I will go back and I will present a bit more about the IDE integration, which partially was shown already, like at the UK Smalltalk meetup. But the code changes browser has changed, and more debugger integration, and also an integration more with Envy. We will dive into that. And then, if I have a little bit more time, just talking a little bit anecdotally. Because we use the Vast AI Assistant in the Vast team, we use the Vast AI Assistant on a daily basis. So just a couple of anecdotes of how we have used it in our development at the daily work. So first off, the Vast AI Assistant goals. It's first important to talk a little bit more about how we approach AI development at Instantiations. First off is that we think that AI should augment the way people work, the existing workflows, be a tool for developers to use, and that means integrating it into the current tools and not have some disconnected tool somewhere. Currently taking a look at the existing tools what people are using and see how AI can of course improve their workflows there. And secondly, in bringing such innovation into an existing product, we always balance stability, the innovation together with stability and long-term sustainability, such that you have some trust in a long-term system. So this is important. And well, these concepts are maybe not new to you, but at Instantiations we have called this, of course, responsible evolution, and it's the way we approach the development of the AI assistant at Instantiations, pretty much in everything that's development work that is happening at Instantiations. So how does this translate, of course, to the Vast AI Assistant goals? Of course, we want to improve the developer productivity and improve your daily workflow. So that's, of course, the high-level goal. But we started off building the AI Assistant by saying, well, we want something that seamlessly integrates into the existing Vast environment, right? A deep integration in there. Not some tool where, like Claude, using it on the side and having it communicate with Smalltalk, of course, an MCP server, for example. Of course, this is also very valuable, but the way we approach the Vast AI Assistant is that it integrates into the current development environment. So we will extend the current development environment. And that means giving the AI the autonomy to explore all your code base such that it's able to give you good suggestions and before proposing any parts of modifications. And secondly, of course, since Smalltalk is a live object environment, we all like well, we don't like debugging, but we like programming in the debugger. So we want to see, of course, more the AI being part of the object environment itself. And then this is part where we say, well, the developer is always in control. That means that we will focus the entire development and the way the tool works such that having a human in the loop of this AI-assisted development is something that works well. All at the same time by still allowing agentic workflows. If you really want to say, well, just let the AI go off and build me the tool and the code and everything, and I don't want to look at it, that should work well as well. But in the first, as a primary objective, we think that everything should work really well by having the AI assist the developer and let the developer be in control. So then I will pass on to Kris, who will show you a bit more how the AI assistant looks like.
Okay. So we set this up as an open source project on GitHub in this repository Vast Platform AI Assistant. So we already had a number of customers who had expressed an interest in collaborating on AI in Vast. So this repository gives us a space to do that. If you're using Vast, then the README explains how to load this, which is basically just download a zip archive of the repository and use the Tonel importer in the configuration maps browser to load that. You will have to select the config map for the Vast version that you're using, which is either 14.1 or 15.0. But I should have an image over here. Okay, where we already loaded it, and I'm having some trouble. Okay, so I can go ahead and open what is the core of the assistant at the moment. So as Johan explained, the goal of the project is to have a deeper integration of AI into Vast, but at the moment, the core of it is this chat interface that allows you to chat with a large language model. So I can try and send a message over here, but then the interface is going to tell me that I do need to set up a model provider and a model first, for which it's also going to open the settings window. I can do that from the options menu over here as well. Now, for model providers, we support two different APIs, the Google Gemini API and the OpenAI Responses API. So at instantiations, we tend to mostly use Google Gemini, as we also use Google Workspace for a number of other things company-wide. So everyone is kind of already set up for using it. But with the Responses API support, you can use other models besides the Google Gemini ones. So obviously the ones of OpenAI, so the GPT models, but also because this API is kind of like a de facto standard, you can use things like Light LLM, which is a router that can translate from other APIs to the Responses API, so that you can use that here as well, like the Anthropic Claude API. And also you can use local models through something like Ollama or LM Studio, which offer the local model through this same Responses API as well. But for the demo here, I'm just going to go ahead and copy my throwaway Gemini API key from here. Okay. And when I save that, it will load the available Gemini models. And then in the models section of the settings, I can set up the models that I actually want to use in chat windows. So I will just set up the Gemini 3.1 Pro Preview Custom Tools, if I can find it, yeah, and save that. So if I would set up multiple models like that, I can pick per chat window which one to use from the options menu, but I only set up the one, so I'll use that to send my message. And then I'm hoping to quickly get a response, okay. So for something a little more interesting, I can ask what are the categories of the methods on AI chat. So this is one class in the implementation of the chat. And for this, the model is going to have to do a function call. So function calls are a way for a model to get additional context apart from what you directly provided in your message. So here, the function call is for the function getClassMethods. And the model is specifying, the class that I asked about as an argument, and then there's a parameter that allows it to specify whether to get the source or not. So in this case, it passed false because it only needs a list of the methods. So we don't show here what the result of the function call is that gets passed back to the models, but you can guess it's just a list of the methods. And crucially for this question, that includes the categories of the methods as well. So from that, I get a summary, just listing what the different categories are. So we support a number of different functions that we make available to the model. So we have the code exploration functions, which allow a model to explore code in your image in kind of the same way that you can in a system browser. So there are functions for getting the definition of a class, getting the hierarchy that a class is the root of, finding senders and implementers of selectors, references to instance variables, and so on. Then we have the code modification functions, which allow the model to modify code, but these don't actually allow it to directly make the changes. They instead get collected in a kind of change set, which you can then browse and selectively apply changes from. So that's something that Johan is going to demonstrate a bit more in detail later on. And then we have the MV addition exploration functions, which allow the model to look at additions of applications and configuration maps in an MV library. So this is the vast native version control system. Then we have a few functions for letting it look at files. So you can selectively make files available in the chat through this add file menu option over here. And then those functions allow the model to list the available files and read sections of them. And then for the last two categories, the last one is a bit similar to the file reading. It's just for reading web pages. And then we have the testing and debugging category, which allow a model to run test cases, and for failing tests, look at the failure, and in particular the stack trace for the failing test. And a bit similarly like that, there's a function for letting a model look at any open debuggers you have in your image, so passing a stack trace to the model. So again, that's something that Johan will demonstrate a bit more in detail later on. There's one more here, the evaluate function. So that one just allows a model to evaluate any Smalltalk expression in your image. So by default, we disable this one since it allows making changes as well in your image, which you maybe don't want. It also allows it to compile things directly bypassing the change set mechanism. But you can enable it, and then you can still choose whether to just always allow any evaluation, or have the interface ask you for each call whether you want to allow it or not. So I will maybe briefly say that these functions are implemented in the AI abstract function class hierarchy. So these classes implement all of the functions that I just discussed. And of course, if you want to add functions of your own, you can just add another subclass. We also provide support for using externally implemented functions using the model context protocol. So this is a bit of a work in progress still, but one way in which this has already been used internally is by our VM developers. So the VM is implemented in C++, and they use C++ IDE to work on that. And this IDE, CLion, offers an MCP server. So by connecting that to the chat in VAST, they can have a chat about the VM from, let's say, both the image perspective and the actual VM source. So I have CLion open here with the source of the VM open there as well. And then I can take the URL for the MCP server, which I'm just going to copy from the documents here and set that up. Okay, and then from the on the functions section, I can just use the reset button, and then I get also the functions that the CLion MCP server offers. So these allow reading files that are open in CLion, modifying them as well, executing terminal commands, and a bunch of other things that the MCP server offers. So it's a bit hard to give like a realistic example of how that has been used that I could quickly explain. But for like a bit more of a toy example, I can ask whether is it possible to have invalid UTF-8 in a Unicode string. So Unicode string is the class in VAST that represents strings using Unicode characters. And I'm going to explicitly ask to explain why or why not. And I'm also going to hint the model towards using the CLion functions. Use your CLion MCP functions to read the VM source code. So as I said, bit of a toy example, but how it's been used is to analyze some hard to find well, edge case bugs that we've got reports about for the VM, which were hard to reproduce. But with the help of Gemini, it was much easier to analyze the stack traces and pinpoint the source of the bug and implement a solution for that in the VM as well. So this might take a little long to generate the actual response. So we see here in the thoughts that the model is using the CLion functions to start looking at the implementation of the primitives for Unicode string in the VM. And yeah, we aren't quite there yet. So I will open a safe chat I have for this with the same question where we already have the final response. So as Gemini indicated here, yes, it is possible to have invalid UTF-8, but only if you bypass the constraints that the VM imposes by using reflection. So it looked at the source of the VM and found that from Unicode string, or the class Unicode string uses a primitive in the VM to create the instance, and that primitive validates whether you're passing a valid UTF-8 byte sequence at instantiation. And then also the methods for modifying a Unicode string impose that constraint as well, as they only allow you to use a Unicode string or a grapheme for modifying a string. And since at instantiation of those, the validation is already checked, the constraint remains imposed. So it does indicate in the final part of the response that yes, you can bypass that, but only if you use reflection. So with the normal public APIs, the constraint of having only valid UTF-8 is imposed. So that's more or less what I wanted to explain. So back to you, Johan.
Yep. That is a story.
Okay. All right. Yeah. So you saw also that you're able to save and open chats across different images, of course. So you're able to take a look at all those things. All right. We'll let it run a little bit in the background. I'll go back to slideware for now. Okay. Good. All right. So a little bit more of, a little bit more. Yeah, Kris.
Oh,
go ahead here. Well, let's just swap.
oh yeah.
All right. So this is then the part of the AI chat, but we started, of course, integrating it, as I mentioned, more into the rest of the IDE. And one thing we already showed at the UK Smalltalk presentation is that when our approach at that time when we were asking for code is that we let the AI put the code pieces in Markdown, right? So pieces of code inside of your chat, and you could click them and you get a differences browser shown here, and so you could merge them in. That was like the first approach. But as we've also seen with Andrei's presentation, there's better ways to have the AI give you code which are more reliable. In the G Toolkit integration was more about using the JSON schemas. We took the approach of also offering functions to let the AI propose code changes. And why was that? Because at first we were thinking we'll just go ahead and actually let it produce code, but we had some system instructions on saying, well, if you have a method, format it in this way, and if you have a class, format it in this way, but the AI would just start to ignore those rules and give you the file-in format inside of the code, snippets and so on. So all those things were impossible to treat. Another thing is that we normally asked it to validate the code. What we do, there is a validate function, which will take a look whether the code, well, first it parses. Does it contain any methods or classes which don't exist in the vast system, because it knows this from an other Smalltalk implementation, or it just hallucinates particular parts. So it had to do that, but it was just ignoring those rules. So we didn't saw that as a viable approach. So the new approach is effectively, as Kris mentioned, using those functions, and in the functions, so when the AI would propose, okay, I want to introduce this class, introduce this method, we will validate it completely and then just return, oh no, this doesn't work, there is an inexistent class and a method which is not implemented, and so on. So those are the advantages on that part. And also, I mean, it's not possible to let the AI remove classes, for example. So if you're busy working on a project, sometimes it will say, or you're just it will say, okay, remove those methods or move those methods. So the functions we're offering there are actually refactorings, right? So we made we create a refactoring browser on top of that. So and before going back to the to that part of the demonstration, also to the thing about the AI-assisted debugging. So we have an integration with the debugger. While you're working on it and you try to run the code, of course, you get debugger open. We allow you to immediately direct the AI to serialize the stack basically, and give it to the AI and say, well, there's a problem there, so it can analyze. And you can do that in the context of a certain conversation, for example. And at the same time, we allow it to run test cases and debug those test cases so it can propose you solutions. This is one of the first examples about more live integration in the rest of the IDE. Of course, more ideas to come is to inspecting the objects or navigating the object memory. Those are things we are going to work on in the future. All right, so I have my, all right, that's back, good. So I'll open a new chat if, so in the meantime, the response also came in, but Kris already explained that clearly. I'll close these. All right, and I'll open a new chat window. All right, so I'll first start asking it, we're working on the vast AI assistant. Describe me what the major components are.
We are working on the vast AI assistant implemented in applications. Starting with the AI prefix, describe its architecture,
So I just do this because I want to scope the AI into, I'm working on this particular project. And it's a sentence I almost use on a daily basis, because of course we're using the AI assistant to develop the AI assistant ourselves as well. So this is normally going quite fast. I'll actually, while this is going, another thing that we allow is that we're using Gemini most of the time, which is a cloud model, but many of the people, of course, we heard the same question here before in the previous talk, is that you want to not give your code to any cloud provider. So we're also support for running local models. And if you go to the settings here, you can providers. So I look at a provider. So I'll click here one. I have LM Studio running locally with a couple of language models installed in it. So I will open the responses API. I have to just copy the URL here. I'll just call it LM Studio. Let me refresh. So these are then listing the models I installed locally on my LM Studio. And now this is becoming an option inside of the AI assistant to choose. I'll open a new window. And in this case, I will, well, I forgot. So in order not to have a long list of models being listed, you also have to select which models you want in your dropdown. So I will use the Quen model here. All right. Let me copy paste the same example, opening a new chat, setting it to the other model, and I'll just let it do the same thing. And you will see this, of course, is a different LLM, and it works a little bit slower, of course, because it's local. But let's go back to the, while this is running in the background, let's go back to the one where I'm using the Gemini model. And okay, so I actually, as Kris explained, you can add your own functions. So why not ask it to, okay, where should I be to actually add another function to the implementation? So, should go relatively fast. So it's investigating, of course, how are these functions defined. So the function call, for example, is getting the definitions for the classes AI abstract function, getting the class method, so it's investigating, and then it's presenting me how I can add a new function to the vast AI assistant. And in this case, because I just asked it how to do it, it's explaining me, it's giving me the examples. Of course, I'm not going to read through them all here. We don't have that much time, but that's fine. I said okay, but please, propose code changes for a mathematical function. With the getting older, huh? Oh, propice. Well, I made a spelling mistake there, but let's see what it makes of it. Normally, so if I'm talking to the AI here and I say, well, I want to do these things and I want to do some code changes, then it will propose me the code changes immediately. But in this case, I just asked it to describe how to do this, and then it will just talk to me. So now, normally, I made a spelling mistake, so demo time, of course. Let's see if it understands that I've tried to propose the changes. Okay. So when you do that, you get a button. So if the AI, during the response generation, it has called these code modification functions, you get this button here at the end of the response, and that opens this code changes browser. And this is the part where it will propose me all the necessary changes, and I, as a developer, am in control to take a look at them and actually, well, merge them or discard them. So you see here, define me a calculate factorial, and then let's take a look what it did for the application. Where is the, well, it used to give me something where it was, okay, doesn't really make sense. So it's just factorial that it gave me. So with another question asked, it was just using the compiler, so that at that time you can say, well, no, I don't want to have a function where it will invoke the compiler because it can start to do anything. So as an example. I see that we're already quite far in time. I also had a demo just to, because I don't know anything about user interface building, so I just tend to use the AI to ask it to generate me a user interface in VAST. I could do that for a simple calculator example, and it brings that up. So I've been using exactly those things here to just give me the information on that. And propose it to me. So you can merge those things in here by selecting them, and then they disappear. And then you see the differences here at the bottom, what happens. So At the same time, I think the local model, demo time. So yeah, if you get an error, you can inspect, debug, and all those things, but you can also retry. Most of the time, this is like a network error, and then we just allow you to continue, for example. So okay, that part of with the local model, it didn't work, but it's going to produce me a response, which is a little bit different, of course, in that sense. So this is the part of the changes browser. And another thing is, for example, if I have an error and I'll just do a zero divide here in a workspace, we have the Ask AI to investigate your stack trace. And if you have multiple windows open, you might want to, you're busy working on developing a piece of project and it might be an error in that context. And you can say, well, report this to the conversation in that particular window, so you're able to continue there. Now it's a completely new one, so I'll just open a new chat window and it will take a look at the stack trace. We are sending that off to the AI and it's taking a look at it. We'll see that it's a zero divide problem, of course. But I'll switch back to the presentation here. As I see, we're already quite far in time. So another thing that we have is the integration with Envy. So the AI is able to look at all the different version history. And this, of course, allows you, what we produce also is a comparison of these versions and we deliver it something. So in this case, for example, I asked it, well, compare me these two versions of the Envy socket interface config map and describe me what changed. And it did actually see it, give me a description of which methods were added and what pieces are changed. And it was able to see, for example, that we did add support for the message peak flag on a socket read operation, for example. So this allows you to take a look and allows it also to zoom in on what particular things might have changed when new bugs would appear or something. So in general, really quickly, we're using this daily by everybody at Fast. So as Kris mentioned, also the VM team, by putting together Smalltalk code and the VM code, we have a globalistic view. So we're able to debug particular VM problems, for example. But it's very it's very useful to do some rapid prototyping, get something working fast, so you can evaluate your ideas. We did that for the code merge view you're seeing here. Also on the diffing algorithm, for example. Test case generation. I hate writing all the things about test cases from scratch, so I prefer to let the AI give me lots of things already that I can start refining and improving afterwards, for example. The exploration of bugs I mentioned a couple of times. And another thing we think is very useful, we rely a lot on external libraries. OpenSSL is wrapped, for example, other things. And you have C code interfaces and me generating and producing external functions, wrappers in Smalltalk for these external C libraries. That's also like repetitive work. And then AI is very good at that. You just point it to the C header files and you say, let me generate a wrapper interface for that in Smalltalk here, and it will produce all the things you need. And then, of course, you will have to refine that, take a look at it, but a lot of the work has been done already. And as I mentioned, we're using this for the development of the AI assistant itself, of course. So, yeah, taking more time than I thought it would be. So there we are. Thank you.